What type of problems are you going to solve today?
Hello. So today I will solve some practice problems on week 12, which were learning theory and reinforcement learning. So those topics I will cover today.
Like earlier sessions, can we go back and see, like, is it stored in YouTube or any other platform?
Yeah, it is. The links are already there. I think in the NPTEL the course homepage. If you go, so those in the left hand side you have those week 1, week 2 tabs, and at the end of it you have this problem solving tab. So there you will get all the live session links. So you can access through those links. All the videos are uploaded in YouTube, so you will get all the YouTube recorded video links for all the live sessions that happen every week. There are 3 live sessions that happen every week for this course, so you will get all those recorded sessions from that. Hello everyone. Is my screen visible? Can anyone confirm? Okay, thank you. So, good afternoon, everyone. Welcome to the NPTEL live session for the course Introduction to Machine Learning. This,
Yes, the
this
screen is visible. Thank you.
so this is week 12 of the of my live sessions. So my name is Owen Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So in this session we will solve some practice problems on week 12 contents. So the week 12 contents were learning theory and reinforcement learning. So these are the topics that we will cover today. And then if you have any questions or doubts regarding these topics, you can also ask me. So let's start the problem solving part of this session. So this is question 1. So this is on learning theory. So generalization error is given by this expression. So epsilon h, which is the generalization error, is the probability of hx is not equal to y, such that x and y are sampled from D. So you have to answer what is D in this. So what is D in this expression? So there are 4 options. The underlying distribution we are trying to estimate, a sample of the underlying distribution, uh, a different distribution that we are using to estimate the true underlying distribution, and option D is the universe of distributions. So you can write your answers in the chat. So you have to find out what is D in this expression of generalization error that is given on the screen. So Shamala Krishnan says option A. So option A is the underlying distribution we are trying to estimate. Okay, so this is one answer I got from the chat. Anyone else? So the correct answer is option A, which is the underlying distribution that we are trying to estimate. So the a distribution for x and y. So x are the input features and y is the output that you will get. So we are trying to estimate the underlying distribution for the x and y values. So that is D. So the x and y pair is sampled from D. So D is the underlying distribution that we are trying to estimate. So option A is the correct answer. Now question 2. The hypothesis function obtained by empirical risk minimization is denoted by this expression. So h hat equals argmin epsilon h. H belongs to capital H. So epsilon h is the empirical risk or empirical error that we say, and h is the hypothesis. This h is the hypothesis, and this is the h hat that that is the optimal hypothesis that we will get after minimizing the empirical risk. So the question is, if h is a class of neural networks, this capital H, which aspect constitutes its space? So what is the space of capital H? So this is the expression for empirical risk minimization. H hat equals argmin epsilon h. Epsilon h is the empirical risk or empirical error, and this h hat is the optimal hypothesis that we will get after minimizing the empirical error. And this H is taken from capital H. So the question is, if this capital H is a class of neural networks, which space constitute this its space? So basically you have to find out the space for capital H. What is this space for capital H is? So there can be multiple correct answers here. The four options are so the space for H is different number of layers, different number of neurons per layer, different values for weights, and different inputs. So what will this H have? if it is a class of neural networks. So Shamala Krishnan says option C, value of weights, the different values of weights. Okay, anyone else? So here we are trying to find out the best fitting neural network out of all the neural networks possible, or from a class of neural networks which is H. So the correct answer here would be C, different values of weights. So H is the class of neural networks, and we are trying to find out the best fitting neural network. So basically we are trying to find out the best fitting values for the weights of the neural network. So the space of H would constitute different values of weights. This is just set of different weights that are possible for the neural network, and this using this argmin expression we are trying to find out the set of weights for the neural network which will minimize this error, empirical error epsilon. So basically the space for H is the different values of weights, because the neural network, the number of layers and number of neurons are already fixed, because we are training the neural network on a given data. So number of neurons and number of layers cannot change during training process, but we can change the weight values for the neural network, and this is what we are doing here. So option C is the correct answer. Option C, different values for weights. Question 3. So the Charnoff-Werding bound for a classifier H, so this bound is also called union bound, for a classifier H indicates how close the empirical error is to the generalized error as a function of the number of samples in the dataset. So this union bound or Charnoff-Werding bound for a classifier H indicates how close the empirical error is to the generalization error or generalized error as a function of number of samples in the dataset. You test it and you find out that increasing the number of samples does not give a more accurate estimate. What could be the problem? So number of samples is this M. M is the number of samples. So you test your hypothesis using this bound, and even if you increase the number of samples, it is not giving you more accurate estimate. So what could be the problem? Because if the M increases, you can see that this upper limit decreases, and so if the upper limit decreases, these two errors, empirical error and this generalization error, would come closer, but it is not happening when you test it. So what could be the problem with your hypothesis or your algorithm? So there are 4 options. A, choice of gamma is unsuitable, so gamma is one of the parameters here. B, the mean is not from Bernoulli distribution. Option C, choice of hypothesis function is wrong. Option D, samples are not IID. So IID means independent and individual data points. So what could be the problem? that your algorithm is not giving more accurate result even if you increase the number of samples, but theoretically it should give better results. So has anyone found out the answer here? Shyamala Krishnan says C and D. Okay. Anyone else? So we know that if we increase the number of samples or the number of training examples, then the empirical error and generalization error would come closer. So the gap between these two errors would reduce. So this is happens generally for any algorithm hypothesis if it is chosen properly for that problem. But if it is not happening, then the main problems could be that choice of the hypothesis is wrong. So the hypothesis is not able to find out the underlying distribution, so it is not able to predict outputs properly. So that is why even if you increase the number of samples, it is not giving you better result. And another reason could be that the samples are not IIDs. So if the samples are not IIDs, then even if you increase the number of samples, it might happen the samples are correlated and they are dependent on each other. So in that case, even if you increase the number of samples, it might not have any effect on the error. So that's why D is also one of the possible reasons. So the C and D, they are the two possible reasons for that, that the choice of the hypothesis could be wrong, and another reason could be that samples are not IITs. So because of these reasons, you might get that the error is these two errors are not coming closer even if you increase the number of samples. So C and D, they are the correct answers. Question 4. There are two statements written here, statement A and statement B. So statement A says that reinforcement learning is a type of unsupervised learning, and statement B says that reinforcement learning does not have labels. So you have to find out which of these two statements is or are correct. So it might happen both the statements are correct or one of these two is correct. So you have to find out that. Statement A says reinforcement learning is a type of unsupervised learning, and statement B says that reinforcement learning does not have labels. Asha says D. So D is statement A is false, statement B is true. And Shyamala Krishnan says statement A is wrong, statement B is right. So both of them are saying that D is the right option. Okay. Anyone else? D is the correct answer for this question. So statement A is reinforcement learning is a type of unsupervised learning. So this is wrong. This is not right. There are three kinds of learnings. So first is unsupervised learning. Second type is supervised learning, and third is reinforcement learning. So this is a different kind of machine learning. So option A is not right, and option B is reinforcement learning does not have labels. And this is true that we have levels in case of supervised learning, and in unsupervised learning we don't have any levels, so that's why we do grouping or clusterings. And in reinforcement learning we don't have any labels as such, so we have these reward or penalty signals that we get from the environment, but those are not labels. So option B is correct, that reinforcement learning does not have labels. So option D is right. Statement A is false, statement B is true. So option D. Now question 5. So aliens challenge you to a complex game that no human has seen before. They give you time to learn the game and develop strategies before the final showdown. You choose to use machine learning because an intelligent machine is your only hope. Which machine learning paradigm should you choose for this? So you have a complex game in hand that you have to learn very fast, and so there are four options. So there are which machine learning paradigm would you choose? So option A is supervised learning, option B is unsupervised learning, option C is reinforcement learning, and option D is use a random number generator, hope for the best. So you have a complex game that you have to learn rapidly or very fast, and you don't have any other ways of learning this. So any other ways of training your machine? So what would be the machine learning paradigm that you would choose? Shyamala Krishnan and Asa has said in the chat that option C is correct. Okay, so C is reinforcement learning. So both of them are telling option C. So correct answer in this question is option C, reinforcement learning. So reinforcement learning is very good at learning complex games or complex strategies that you need for a game, which supervised and unsupervised learning are not able to do, because for these learnings we need a training data already prepared. But in reinforcement learning, it tries to play the game for multiple times and try to readjust his strategy every time. So that way the agent learns. And for a complex game, that's why reinforcement learning is best suited. So reinforcement learning is optimal for building agents for complex games where no expert trajectories exist. So if you have expert trajectories, like the data is already available, that if you do this and this will be the output, then supervised learning is the best choice. But in case of complex games, you don't have anything like that. You don't have those trajectories available to it until you play the game. So that's why reinforcement learning agents are much better at those things. So option C would be the correct answer. So now moving on to question 6. In the Pavlov's dog experiment, what is the input signal to the dog and what is the reward? So what is the input signal and what is the reward to the dog in Pavlov's experiment? And there are 4 options. Option A, bail and digestion. So bail is the input signal, digestion is the reward. Option B is food and praise. Option C is food and digestion. Option D is bail and food. So what is the input signal to the dog and what is the reward in Pavlov's experiment? And this experiment is very similar to what we do in reinforcement learning. So that's why we have these signals and rewards concept here also. Shyamala Krishnan says bail is a signal and food is reward, and Asha says D, which is the same answer, bail and food. Any other answers? So option D is the correct answer. So both of you have written the correct answer in the chat. Bail and food. Bail is the input signal and food is the reward. So whenever the input signal is given to the god, which is the bell, whenever the bell is rang, so the food is served to the dog. So food is the reward. So input signal, we in reinforcement learning, whenever we give some input signal to the system, it changes its state and also gives some reward. The environment gives some reward to the agent, and the same thing is happening in Pavlov's experiment, that whenever the bell is rang, so the food is also served. So food serves as the reward. So option D is the correct answer. So this is very similar to what we do in reinforcement learning. Question 7. What is a policy in reinforcement learning? The 4 options are there. A mapping from states to action, a mapping from states to rewards, a mapping from actions to rewards, a mapping from actions to next state. So policy is a mapping or a function from the set of values to some another set of values. So what is that mapping? From which domain it is mapping to which range? Shyamala Krishnan says states to actions, which is option A here. Asasha C, which is mapping from actions to rewards. Okay, there are 2 different answers are in the chat. One says A, another person says C. Anyone else? Does anyone think any of these 2 are correct, or some other option would be correct here? So policy is written as pi in reinforcement learning, which is a mapping from S to A. So given a state, so the S represents set of states, and A represents set of actions. So given a state, policy gives you the best possible action for that state. So basically the objective in reinforcement learning is to learn the best policy by minimizing the total cumulative reward in an episode. So this is a mapping from states to actions. So if you have a state S, small s, so pi s is an action. So it is a mapping from or function from states to actions. So option A is the correct answer. Now moving on to question 8. You want to make an RL agent for a game where two players compete to win, like in chess or go in some other game. Which among the given would be the best approach for this? So you want to train an RL agent for a game where two players play. So a two-player game you would try to learn with an RL agent. So what would be the best approach? Option A is play against the best human player. So you make the RL agent play against the best human player to learn the best policy or best strategy to win the game. Option B is iteratively play against the best version of itself. And option C is play against a supervised agent trained on demonstration of the best players. Option D is watch thousands of games being played and learn the patterns in an unsupervised manner. So these are the four possible approaches, and which would be the best approach to train an RL agent in a two-player game. So Shamala Krishnan and Asa said B in the chat. So both of them are saying B, which is iteratively play against the best version of itself. The correct answer is B. So iteratively play against the best version of itself, which is the best approach, and this is the approach that is taken in most of the complex RL agents like Alpha Zero, if you have heard of it. So it plays against its best version, and that way it learn to make its strategy better. And playing against best human player is not possible because it would take a lot of time, but playing against the agent itself is much lesser time consuming, and it is the best way of learning for the agent. So option B, that playing against the best version of itself, is the correct answer. Now question 9, which type of feedback does an agent in reinforcement learning receive? Option A is predictions, option B is levels, option C is clusters, option D is rewards or penalties. So what type of feedback does an agent, RL agent, receive? Shyamala Krishnan says D. Asha also says D. So both of them says D. D. So D is rewards and penalties, or rewards or penalties. Anyone else? D is the correct answer. So you will get rewards or penalties in reinforcement learning. So an agent takes some action, and based on that action it gets a new state, and also it receives some reward or penalty from the environment, and based on that it changes or tweaks its strategy in order to maximize the total cumulative reward, and that way it functions. So option D, it receives rewards or penalties from the environment. Option 10, question 10. You were designing a reinforcement learning agent for a racing game. Among the following reward schemes, which one leads to the best performance of the agent? So there are 4 options. So you are building a reinforcement learning agent for a racing game. So option A is +5 reward for reaching the finish line and -1 for going off the road. +5 for reaching the finish line, -0.1 for every second that passes before the agent reaches the finish line. +5 for reaching the finish line, -0.1 for every second that passes before the agent reaches the finish line, and +1 for agent going off the road. Option D is -5 for reaching the finish line, plus 0.1 for every second that passes before the agent reaches the finish line. So which reward function would lead you to the best performance of the agent? Shyamala Krishnan says B and Asa also says B. Okay. So does anyone think any other option should be correct other than B? So we are building a reinforcement learning agent for a racing game. So for a racing game, the first thing that we need is that if whenever the agent reaches the finish line, that it ends the race, then it should receive a positive reward. So plus 5 for reaching the finish line is fine. And then as it is a racing game, so we want the agent to finish the race as fast as possible. So for every second that passes before the agent reaches the finish line, it should get a negative reward, so that it tries to minimize that penalty. So this minus any negative reward is a penalty, so it would try to minimize that total penalty that it would receive before finishing the race. So it should get a negative reward for every second that passes before the agent reaches the finish line. So this minus 0.1 for every second, that is also fine. So option B is correct. So option C also has these two rewards, but this plus 1 for the agent going off the road is not correct. It should have been a negative reward, because if it goes off the road, then it should not get a reward, it should get a penalty. So this third is not right. And from that point of view, B is the correct, that it should receive a positive reward for finishing the race, and it should get a very small negative reward for every second that passes before it reaches the finish line. So option B is the correct answer. Question 11, and this is the last question. So you have been recruited as a leading engineer by some corporation which wants to enter this self driving car market. So it wants to create a reinforcement learning agent for self driving cars. So in the context of the standard reinforcement learning framework, what would you classify as the state and actions? For a self driving car environment or an agent, what should be the states and actions? And note that the system does not have access to the previous states. So we are using a Markov decision process. So in Markov processes, it only has access to the current state, not the previous states or history of states. So what should be the states and actions? So there are four options. Option A is a state should constitute current steering wheel position, current pedal position, current speed. An action should constitute turn the steering wheel and press pedals. Option B says states current steering wheel position, current pedal position, current acceleration, and actions should be turn the steering wheel and press pedals. Option C is same, or the states are same for A, that steering wheel position, pedal position and speed, and actions are change direction and change speed. And option D is state should be the current steering wheel position, pedal position and acceleration, and action should be change direction and change speed. So what should be in state and what should be in actions? So what are the features that state variable should have, and what are the features that the action variable should have? Shamala Krishnan says A. Okay, so A is steering wheel position, pedal position, speed, and actions are turning the steering wheel and pressing the pedal. So anyone else? So in any reinforcement learning framework, the state should contain all the features or all the variables that the agent should know to take an action or make any decision or take an action. So state should contain all the things that it should know to take an action. So in our case, for a self-driving car, the things that the agent should know in order to drive the car, the current steering wheel position it should know, and all the pedal positions it should know, like all the three different pedals it should know what are the positions of those pedals right now, and also the current speed of the car. Acceleration is not very important, rather speed is important, whether you want to press brake or whether you want to accelerate. So for those things current speed is the most important thing. So the steering wheel position, pedal position, current speed, these are the three things that these are the three most important things that the agent should know in order to take an action. And what should be the actions? So action should contain turning the steering wheel, so this is a basic action, and pressing pedals. So these are the actions that the agent can take, that it can turn the steering wheel, and it can press the different pedals. So these are the actions that it can take, and by taking those actions it changes the state and also gets some reward from the environment. So these are the states and actions. Option A is the correct answer. So state should contain all the variables that it should know in order to take an action. Also it should be noted that it doesn't have access to the previous states, so you need all the variables that can define the state of the system best. So these are the three features that can define the state of the system properly, and the actions are turning the steering wheel and pressing the pedals. Using this it can drive the car. So these are the actions. So option A would be the correct answer here. So these are the questions that I wanted to discuss today. So if you have any questions or doubts regarding these practice problems that I have discussed, you can ask, or if you have any other questions or doubts, you can also ask. Does anyone have any doubts?
No, thank you.
Okay, thank you. So if there are no other questions or doubts, then we can leave this meeting and I will end this meeting. Thank you everyone.
Yeah, this is the last meeting, no?
Yeah, this is the last live session from my side.
Yeah, thank you for all the sessions. We really enjoyed all the sessions with you.
Thank you.
Thank you so much for all your hard work and efforts.
Thank you. I appreciate your praise. So
thank you so much. Yeah. Bye.